Hi and welcome to my tutorial on empirical formulae. So today I've got a bunch of questions and let's have a see if you can do any of them. So we'll start off with question 1, best place to start. 1.15 grams of sodium reacted with 0.8 grams of sulfur. Calculate the empirical formulae of sodium sulfide. So I'll give you a quick pause and off we go again. So 1.15 over 23 is 0.05 moles, and 0.8 over 32.1 is 0.024922 blah blah blah, and that gives you 0.0249 moles. So 0.05 over 0.0249 is 2.00625, which is roughly 2. This is where you start rounding in an empirical formula question when they want a whole number, and anything by itself over itself is 1, so it's Na2S for the empirical formulae. And for question 2, 1.35 grams of aluminium was heated in oxygen until there was no further gain in weight. The white oxide ash formed weighed 2.55 grams. Deduce the empirical formulae of aluminium oxide. So, give me a quick pause. Okay, moving on to question 2. 1.35 grams of aluminium and 2.55 grams of the unknown oxide formed. So to find the oxygen used, we need to take 1.35 from 2.55, which is 1.2 grams. 1.35 over 27.6 is 0.05 moles, and 1.2 over 16 is 0.075 moles. So we need to divide by the smallest. 0.05 and 0.05 is 1, and 0.075 over 0.05 is 1.5, which is approximately 2. And so the empirical formula is AlO2, like that. And moving on to question 3. A chlorinated hydrocarbon compound when analysed consists of 24.24% carbon, 4.04% hydrogen, 71.72% chlorine, and the molecular mass was found to be 99 from another experiment. Deduce the empirical and the molecular formulae. So, looking at the question now, 24.24 over 12 is 2.02, and 4.04 over 1 is 4.04. 71.72 is over 35.5 is 2.0202. So dividing by the smallest, we have 2.02 over 2.02, which is 1, and 4.04 over 2.02 is 2, and 2.0202 is 1, about 1. So empirical is CH2Cl, and then working out the MR for that, we get 12 plus 2 times 1 plus 35.5 is 49.5. So dividing it by 2, divide 99 over 49.5, we get 2. So 2 times CH2Cl, we get C2H4Cl2, and that is the molecular. So that must be the actual formulae. And moving on to question 4. A gas formed by the combination of hydrogen and sulfur consisted of 5.88% hydrogen and 94.12% sulfur. What is its empirical formulae? Okay, moving on. .88 over 1 is 5.88, and 94.12 over 32.1 is 2.93208. 5.88 over 2.93208 is approximately 2, and 2.93208 over 2.93208 is 1, so the empirical formula must be H2S. so its empirical formula is H2S. And 7.75 grams of an alcohol consisted of 3.00 grams of carbon, 0.75 grams of hydrogen, and 4 grams of oxygen. If its molecular mass is 62, work out the molecular formulae. So it's question 5. (3.00/12) is 0.25 mole, 0.75/1 is 0.75 mole, and 4/16 is 0.25 mole. Make that 2 just a bit clearer. And 0.25/0.25 is 1. And 0.75/0.25 is 3, and 0.25/0.25 again is 1. So the empirical formula is CH3O, and the molecular is 12 plus 3 plus 16 for the mass of this, and 62/31 is 2 again. So 2 times C times H3 times O is C2H6O2. So that is the molecular formula. A chlorinated hydrocarbon molecule consisted of 37.21% carbon, 7.75% hydrogen, and 55.04% chlorine by mass. Deduce its empirical formulae. So that's question 6. So 37.21/12 is 3.10083, 7.75/1 is 7.75, and 55.04/35.5 is 1.5504 moles. So divided by the smallest, which is 1.5504, we get 2. 1.5504, sorry, 7.75/1.5504 is 5, and 1. So empirical is C2H5Cl. So I'm going to put EMP for short. And for question 7, a brominated hydrocarbon consisted of 12.77% carbon, 2.13% hydrogen, and 85.1% bromine by mass. If its molecular mass is 188, deduce the molecular formula of the molecule. So I'll give you a quick pause. And we're on the road again, down to question 7. Going for the burn. 12.77/12 is 1.0641. 2.13/1 is 2.13. And 85.1/79.9 is 1.06508 ... And divided by the smallest, which is 1.0641, we get 1 to 2 to 1. So it's CH2Br for empirical formulae, and the molecular formulae is the 188 of the, which is of the molecule. So it's molecule over empirical. And so it's 12 plus 2 plus 79.9. And that gives us about 2. So 2 times CH2Br is C2H4Br2. And now for the final question. You should be getting pretty good at these by now. An oxide of copper containing 80% copper and 20% oxygen by mass. An oxide of copper. What is the formula of the copper oxide? So we need to do the same thing again, just with copper and oxygen. So give you a set applause. Okay, so now we have 80 over 63.5, which is 1.25984 moles, or to 366 figs, it's 1.259 moles, but we don't do that. We use the full calculator display when doing empirical formulae. So we get 1 for copper, and 20 over 16 is 1.25 moles, so dividing it by that we get 0.99218, which is 1. So the empirical formulae is CuO. And that's it for this tutorial. So thank you for watching.